morning. It's great to be here. So I'm Will Hawkins. I'm a lecturer in structural engineering design at the University of Bath. So I have quite a wide range of research interests. So I'm a structural engineer by background, and I do research around structural design optimization, construction materials, life cycle assessment. So measuring the embodied carbon of buildings, construction, how those things are then decarbonizing into the future, other things like reuse and circular economy. So I keep myself busy. But today I'm going to be talking specifically about a project, a collaboration that I've recently been leading between Bath and North East Somerset Council, or BANES, and the university. Um, so just a little bit of background, and this kind of covers things that Andrew said already. So in the UK, buildings or the built environment controls something roughly, I mean, there are different statistics, but something around 25% of our total emissions, total consumption-based emissions, that would be. And that is split into two important distinctions. So the first is embodied carbon. So just to remind you, that is the emissions associated with the production of construction materials, the construction activities and demolition, etc. And that is distinct from the operational carbon of buildings, which is associated with their heating, lighting, cooling, ventilation. So the electricity and fossil fuels that are used in the operation of those buildings. And at present, the operational carbon emissions in the UK are quite a bit bigger than embodied carbon. And that's because of all of these old buildings that we have that are not particularly efficient. But when we look at new buildings, that's where we see that embodied carbon can be a significant portion of the whole life carbon of a building. And actually, if we have a net zero building, by one definition, that embodied carbon could creep up to be 100% if the operational carbon is effectively zero. And we'll touch on that idea as we go through. Okay, again, sticking with the sort of national background. So currently, the building regulations in Part L dictate how energy efficient buildings have to be. So this only applies to the operational energy efficiency of new buildings. It's been in place since 2006 and has gradually been ratcheting up in terms of having improved operational efficiency of buildings, most recently in 2022, and is about to get superseded by the Future Homes Standard, which again focuses only on the operational carbon portion. It brings further reductions, and it has what's called a fabric first approach, which is supposed to result in energy efficient buildings. It does include on-site energy generation through things like solar panels, but that's only optional. And it has been quite widely criticized by some of the groups that Andrew mentioned as having a lack of ambition. It certainly couldn't be described as zero carbon. So that, again, only covers the operational side. In terms of the embodied carbon, there was a proposal back in 2023 called Part Z. So it was proposed as an extra part of the UK's building regulations to look at whole life carbon, which includes operational and embodied carbon. And so this had a lot of industry backing, and there was a parliamentary bill that was proposed, but unfortunately rejected in 2023. And instead, the government has commissioned further research into what the impacts of requiring whole life carbon assessments would be. So the first step that was proposed here was just to measure the whole life carbon rather than imposing a cap and then reducing that cap down. Okay, so that's the national policy. So what's been going on in BANES? Well, for more than 2 years now, through an update to BANES's local plan, they introduced three new sustainable planning policies for new buildings. So I'll go through those. The first one, which is called SCR6, relates to all new build residential buildings. And so I'll try not to go too technical here, but hopefully these numbers are useful just in terms of comparisons. So it requires a space heating demand for the new building. And again, this is all theoretically predicted via a standard methodology of less than 30 kilowatt hours per meter squared per annum, and a total energy use of 40. And critically here, it requires the on-site renewable generation to match total energy use. And you can only offset the difference if you've demonstrated that it is infeasible to match the two together. So this is a really important policy. It applies to all new houses in Baines. It has done since the beginning of 2023, and it's the policy that I'm going to talk about in most detail in this talk tonight. But there are other policies as well. So SCR 7 relates to major non-residential new build developments, and those are developments above 1,000 square meters. And effectively, this is the same, but it's in slightly different language. So what it says is you have to achieve 100% operational carbon reduction relative to the Part L target emission rate. So 100% reduction leaves you with 0%. This is also a net zero building, but the numbers and the way that it's calculated is slightly different to align with the way that Part L works. It also stipulates a fabric first approach with on-site renewables. And again, if this is demonstrably infeasible, you are allowed to offset the difference, and Baines sets the offset price if that is what's required. And then finally, and kind of most excitingly for me as a structural engineer, policy SCR 8, which applies to large developments, which is residential above 50 dwellings or non-residential over 5,000 square meters. It was the first policy in the UK to not only require you to measure embodied carbon, but also to impose a limit, which in this case is 900 kilograms of carbon dioxide per meter squared, and that's the internal floor area of the building. And that includes what we call in life cycle assessment speak modules A1 to 5, which is cradle to completion, which is basically to get to the stage of the building being built. And so you're ignoring any hypothetical future maintenance or hypothetical future demolition of that building just to complete the building. That includes the substructure, superstructure, and finishes, and no offsetting was allowed in this case. So there's quite a few technical things going on here, but the really exciting thing is that all of these policies were the first of their kind in the UK. And they're very aligned with the kind of things that myself and colleagues in the Department of Architecture and Civil Engineering at the University of Bath have been researching for decades, and it was just too much of a good opportunity to have on our doorstep these policies being implemented. So I'll get to that in a second, but first of all, just as a sort of comparison against a couple of these background things that I've mentioned. So the current Part L, and this is the Future Home Standard, and this is our Baines policy. So if we look at the space heating requirements, I mentioned that in Baines that's 30. That compares to a range of 50 to 80 currently required for new buildings. So this is a real step change. Similarly, with the total energy use has come down to less than half. There are things like U values, so that's the how effective the insulation is in floors, walls, roofs, and windows. There are minimum values for those set by Baines as well, which again go beyond what's required nationally as a minimum standard. Other things that we'll talk about, which are other important parameters about operational efficiency, include air permeability, so the rate at which external air replaces the internal air in a building. The more airtight your building is, the less you have to heat it and the more efficient it can be. So again, we have lower suggested targets by Baines than would be required by default. And again, there's no mention of renewables or solar PV or embodied carbon, which are things that have come in through Baines. Okay, so that's the background and the policy. And so, as I said, this just felt like such a good opportunity for the council and the university to be working together. So towards the end of 2022, we applied to the university for some funding through our policy support fund, and were given a modest sum to do a 6-month pilot study, and that was between January and July 2023. So that perfectly coincided with the first 6 months of these policies being in place. And I'll talk about some of the results and some of the findings and what we did in a second. I'm also happy to say that we're currently doing a second phase through the same funding scheme. So 2 years later, a similar team has come together, again working with Baines, to track how the implementation of that policy has been going and what might have changed. Here you can see the team. So we have myself, we have other academics people like Andy, Steve, and we have people from Baines and also a couple of other local organisations who've been involved as well. So we have a local architect, Alex Bell, and we have input from the Southwest Net Zero Hub as well. And special mention for Joris and Ellie, who are the people who actually have done the work, the researchers, rather than the people who organise and talk about it like me. Okay, so what are the aims of this collaboration? Well, first of all, it's to understand the industry's adoption of these policies and the influence on building design. Secondly, to determine the reception of the policies by practitioners and how those might have changed over time. And finally, to inform future development of these policies, not only in Baines, but also beyond as well. So in the next few slides, we're going to take a deep dive into answering the question of what happens when you introduce policies like these that are quite radical, or certainly were radical at the time, and require all new buildings to be, effectively net zero in operation. So how did we do it? So first of all, we simply analyzed all of the planning applications that were coming in, and we've done that in both phase one, 2023, and phase two, 2025. So all new residential buildings have to submit building performance data through a spreadsheet tool that Baines developed, and this is actually the same one that Cornwall used. So Cornwall and Baines developed this tool together. So that gives us plenty of data about the claims for the performance of these buildings that come through during the planning application. So we've analysed these. And then for policy SCR7, which to remind you is for non-residential buildings, and policy SCR8, which is for major developments, we're looking at those on an individual basis because the sample size is quite small. So in addition to looking at the planning applications themselves, we also sent out a survey, a questionnaire, to anyone who submitted an application during these study periods. And that survey asked about the applicant's experience, their experience in designing sustainable buildings, and their experience with the policy, as well as what they think the impacts of the policy is going to be. And then this is another one that we actually are going to be doing in the next couple of weeks, which are interviews with more experienced applicants. So we're going to be interviewing 5 or 6 people who've had lots of experience with this policy, who submit applications on a kind of monthly basis to Baines, and talking to them to get their experience, and particularly talking about how their response has changed and how their practice has been affected by this. So today, because we don't have results for this part, the interviews, I'm just going to be talking about the planning application and the survey responses. Okay, so here's an overview of the applications that we've analysed. On the left here in phase one, and on the right in phase two. So phase one at the beginning of the policy, phase two, 2 years later. And these are looking at the initial planning applications that come in that are specifically subject to SCR6. So the majority of these are just 1 or 2 houses. By volume, the bulk of the applications that come in are quite small scale. And in 2023, just under half of the initial applications were compliant with this policy. So they had submitted, they'd done everything that Baines had asked them to. They'd done the analysis of the operational performance of their building, and they demonstrated that their building was compliant. But half of them were non-compliant, and that was for a variety of reasons. So that was partly because they were aware of the policy. In fact, mostly it was because they weren't aware of the policy, actually. That they'd either submitted the old checklist before the new policy came in, or they just hadn't submitted anything at all, which suggested a lack of awareness. Only in very few cases do we see them submitting all the correct documentation, but basically saying, no, my building is not capable of meeting these targets. And as we move into 2025, quite disappointingly, the number of compliant applicants actually hasn't increased. There's still a large minority of applications that miss the documents. Now, that isn't to say that these are being rejected, but what it does mean is that a planning officer has to then go back to that applicant and say, actually, we were expecting a response to SCR6, and we'll consider your application when we have that. So it's really important actually to say that there are actually, so far, there are no buildings that have been rejected on the grounds of this particular policy. But there are plenty that have had to go back and say, yes, we'd like to see that. So applications that are not compliant are due to submitting incorrect documents. that suggests a lack of awareness of the policy rather than a lack of an ability to meet the targets. Um, Unfortunately, we're seeing limited progress based on our sample size. And as I mentioned, no applications have yet actually been outright refused on these policies. Okay, so this graph might look a little bit intimidating. On the y-axis here, this is the total amount of renewable energy, and on the x-axis is the total energy use. And to have a net zero building, your building needs to be in the green, where the amount that your building is generating over the course of a year exceeds the amount that your building is predicted to consume over the course of the year. Um, so you can see that most of the applications that were submitted are quite close to this line. And actually, this total energy use target of 40, nobody was really close to that. So the conclusion here, or the finding here, is that it's quite challenging to match the energy consumption with the energy production. In order to get that to work, you pretty much have to flood the whole roof with PV panels and then try and get the operational performance of the building down as low as possible until that matches. That's the standard response that we've seen. So even though 40 kilowatt hours per square meter is much better than current building regulations, these buildings are significantly more efficient because of the requirement to be net zero overall. Um, there is limited evidence based on the phase two that it's getting easier to do this. And we hypothesize, although we still need to wait for these interviews and the rest of the questionnaires to see if this is true, that the reduced cost and increased efficiency of solar PV panels has actually made it easier to sort of balance the energy books in this way. But these are some of the kind of stories that are coming out here. Um, okay, so again, these are some more graphs, and you don't have to worry too much about the numbers if graphs are not your thing. But there are some really important stories that come out of here. So I want to talk about air permeability specifically, and this is looking at all the different applications and what they claimed the air permeability of their building is going to be. This is a really important parameter because unlike wall U values or the PV panels on the roof, it's it's very hard to reliably predict what the air permeability of your building is going to be until you've actually built it and tested it, because it all comes down to things like tiny gaps between components and the quality of the build. And there's a lot of people coming in with five. So the lower you get this number, the less energy your building is going to need because it's more airtight. And a very, very good air permeability, a passive house standard would be something like zero point 0.6. 3 is the recommended target by B&NES, and 5 can be considered a kind of default value for a new home. And what's been really interesting that we've seen is that a lot of claims for the air permeability are very, very low, getting towards passive house standards. And so it raises this question of whether that's actually going to be achieved through to construction. And even if it is achieved, how you verify that. Basically, you have to build a building and then do an air pressure test and then cross your fingers and see where this number comes out as. So that raised some interesting discussions that we've had with ourselves and B&NES. So the air permeability values are often highly optimistic and can only be verified through construction. The U values, like I said, are a bit more straightforward. A lot of people adopting the recommended U values, but again, lower U values mean a more efficient building. And we see in order to get this space heating right down for this target to work, people are having to specify very, very low U values, which is great in terms of having a building that is theoretically very, very efficient. In terms of how people are providing the heat, um, heat pumps were universal. So again, in order to meet these requirements, you need a heat pump. The efficiency of a heat pump is the only thing that's going to get you towards balancing the books in terms of energy. And we also saw quite a high prevalence of technologies like mechanical ventilation with heat recovery, which again is one of the more efficient ways of avoiding heat losses in your building. So I think the story here is that these are very, very efficient buildings that are being proposed, um, and far beyond existing norms. So that's all I'm going to talk about policy SCR6. That was the bulk of the applications. In terms of major developments, we actually unfortunately only had a handful of samples. So in terms of the residential operational carbon, This was quite hard to achieve. In fact, both of the larger developments where we see multiple stories had to be in discussions about offsetting the difference between the energy generation and the energy consumption. And this is because if you have building typologies with multiple stories, 5 stories, 6 stories, um, you have a lot more occupants and you have a lot more building to heat and relatively lower roof space, so like footprint. And so that's been shown to be quite difficult to achieve in practice. But then that's where this offsetting comes in. And again, because the requirement is that you have to demonstrably try your best to achieve it, we're still seeing a step change in the efficiency of the buildings. And then policy SCR8, which was the embodied carbon. So far, we've analyzed two major developments, and the target was 900 kilograms per meter squared, and both of them comfortably achieved it, despite not having particularly efficient building frames from an embodied carbon perspective. They were basically using in situ reinforced concrete. There are there tend to be much lower carbon alternatives to those. So what that tells us is this cap of 900. It's very exciting because it's the first in the UK, but it's quite generous. And actually, developers are not having to do anything different in order to meet this. The thing that they are having to do is actually do this assessment, which is a good first step. Okay, I'll get onto the questionnaire. So I've only got the responses from phase one at the moment. We're still conducting the phase two questionnaires. But in phase one, we had 24 responses, which was 65%. The majority of our respondents were either architects or planning consultants, and they're typically the bread and butter of these people was small scale residential developments. So we had some diversity, but there was generally a trend of who these people were. Um, there was a wide range of the experience that they said they had with energy systems and renewables, so doing the energy modeling that's required, and the environmental and sustainability assessment. So yeah, this is a mixed group of people with different amounts of experience. So we asked them how clear the policy was to follow, how well the policy was communicated, um, and the requirements of the policy and the timeliness. And you can see in these results, the majority of them are red. So just to remind you, these questionnaires went out in the 6 months following the new adoption of the policy. So it was all very new. And I think the message that we got here is that there was a generally negative view of the policy communication. I think Baines did their best with events and consultations and making these things available several years before they were implemented. But despite that, I think you can kind of never do enough. So it'll be interesting to see in phase two whether this has moved as people have got more comfortable and more used to the policies. So we also asked them which aspect of the policy they found most difficult and which ones had affected their design process the most. And again, there's a huge variation. And what that tells us, and was also true in the written responses to our survey, is that some designers said, this is great, this is what we do anyway, I do this modeling anyway, and I want to produce these kind of homes, so I'm glad that it's now part of the thing. But many others said, what are you talking about? We don't know how to do this. And they were perhaps the designers who were outsourcing some of this work, some of this analysis to external consultants, which obviously comes with a cost uplift. So in general, if there was any trend here, it was that providing sufficient on-site energy to match renewables was the hardest part of the policy to reach, and the total energy use was actually relatively straightforward. Um, Okay, what else did we ask them about? So we asked them about the wider impact of the policies and a few more positive responses here. That the majority of our respondents thought that the policy would be effective in reducing real embodied CO2 emissions and operational CO2 emissions. So it's quite interesting. This one actually is slightly contradicted by our analysis, which says that the embodied carbon cap is perhaps too high to be influencing the designs people are submitting. But perhaps people are unaware of that, or perhaps people think that just measuring it is enough to make people aware of where these embodied carbon hotspots are. In terms of cost savings in the long term, this was a mixed bag, but there was very much consensus over the increased anticipated costs to achieve our planning applications. So Baines did do a cost study before they implemented these policies, and they estimated what the cost uplift would be to construct houses under these policies. And it varied depending on building typology, but all of the cost uplift was less than 5%. But when we asked people about the cost to achieve planning applications, there was a universal agreement that it would increase the costs. And that's because there's extra detail required to do this kind of analysis at planning stage. If you speak to any sustainable building designer, they say you should be doing these kind of assessments as early as possible so that the results of them can drive the design, you know, more fundamentally than just do you use a heat pump, more fundamentally than just how thick is the insulation, but things like, you know, how much glazing do you use? How do you angle the roof to maximize solar PV? These are planning stage decisions that this is trying to drive, but that does come with additional workload. Um, okay, so that's just a kind of zip through some of the highlights of the results that we found. If you're interested, then we have a couple of publications. We have quite a comprehensive report that was published at the end of this first phase in October 2023, and a slightly more condensed paper that was published as part of the Key Cities Innovation Network through central government. And there'll be a follow-up to this report in the coming months based on the phase 2 results as well. So I'll finish talking soon. I'll just remind you of the key findings. So the key finding number 1 is that we see significant impacts on the building designs. We weren't able to do a direct before and after comparison because before the policy, we didn't have the data on the performance of these buildings. But we can say that these are very, very efficient buildings that theoretically meet net zero targets. We see that nearly all buildings can comply with these requirements. But, so where they've done the analysis, they've made it work. So they're not buildings that are just inherently incapable theoretically. The solutions include efficient heating and ventilation strategies. The solutions include PV panels across the whole roof. There are some concerns we found about optimistic air tightness and also some optimistic claims about the PV generation. And we still don't know how well these projects are going to be translated through to construction. Unfortunately, even the applications that we looked at in 2023, very few of those have actually been completed yet for us to be able to say, to compare what was promised at planning stage and what was actually built in the end. Number 2, I think it's fair to say that we did see concerns from building designers, from practitioners. We found that they had variable levels of existing expertise. And universally, they had cost concerns, particularly at the early design stages. So the cost of getting planning permission, they said that would increase. And this is because there's additional design detail required at planning stage. This is a comment that came through quite a lot. We wouldn't normally have enough knowledge of the building to be able to do this kind of assessment at planning stage. And so they're having to kind of front load some of their design. And then finally, in terms of the wider impact, I think it's fair to say that this policy has been driving uptake of knowledge and skills, and we'll hope to evidence that through our phase 2 questionnaire. It's had a limited direct impact on application refusals. So I think directly it hasn't reduced the number of buildings that are getting planning permission. And we're definitely likely to see reduced emissions and energy demand, although, again, we'd love to get in there in the long term and actually monitor these buildings to see whether the claims being made at planning stage make it through construction and then through occupation as well. And so in terms of the future work, we're always keen to do more research. We'd like to expand the study temporally, so to track these changes further over time to follow projects to occupation. So Andrew also mentioned other local authorities who are adopting similar policies. So Cornwall is one, Bristol just down the road from us as well, are hoping to adopt their similar policies soon. And so this would give us a much more diverse range of applications and buildings to study. And then also, I think some of our highlights have shown that perhaps just as a bunch of engineers, we might not be the best people to really understand how to respond to some of these policy responses, and actually policy experts and social scientists would be the people to bring on board in future studies. So watch this space, and that is the end of me.